Okay, so in this video we begin to look at some more examples of factoring things that are a difference of squares, or that may be a difference of squares. So again, we recognize as we look at this problem, 4x squared minus 25, that both of those things are squared, they're being subtracted. So we again write down, what do I square to get the one? What do I square to get the other? And write them down as plus and minus. Alright, so this would factor as 2x plus 5 and 2x minus 5. Okay, so let's move on to example 2. Now, as we look at example 2, we say, well, neither one of those are squares, a number times itself, or a nice integer anyway. But we also recognize, hey, we can pull a common factor out of each one of those. In fact, 8 goes into both of them. So let's take the 8 out. And when we do so, we now find we're left with x squared minus 9. Well, x squared minus 9, that is a difference of squares. So again, we can write down what I square to get x, what I square to get 9, and write it down as plus and minus. And that's generally how factoring a difference of squares works. Now, in the examples we're going to do in a moment here, we're going to kind of turn them up a little bit and make them a little bit more involved. So moving on to example 3. So in this example we have 20x cubed minus 5x. Again, starting off, this is not fitting the format of a difference of squares, but take a moment, pause the video, and factor out the common factor. So you find the common factor is 5x, and when you take 5x out, we're now left with 4x squared minus 1, both of which qualify as a square, and so we can continue on from there. That would be 2x plus 1 and 2x minus 1. Okay, so let's move on to two more examples here of factoring. So on to example 4, and then we'll do one last example after that. So here we have 36x squared minus 64. This actually can be done a couple of ways. My advice is just always get in the habit of looking for a common factor. So let's find that common factor. We look at 36 and we look at 64, and we say to ourselves, hey, 4 will go into both of those. So pull it out. It gives me a 9x squared minus 16. And then I can continue to factor 9x squared minus 16 because it's a difference of squares. I get 3x plus 4 and 3x minus 4. Now, unlike the problems that we had done a few moments ago, where we took out a common factor, this actually started as a difference of squares to begin with. So you could have done this problem by factoring it right off as a difference of squares. So that would have been 6x plus 8 and 6x minus 8. But then if you look at those two expressions, 6x plus 8 and 6x minus 8, you will find that, hey, both of those also have a common factor. I can take a 2 out of the 6x plus 8. I can take a 2 out of the 6x minus 8. Oops. Got to actually take the 2 out. And then 2 times 2 is 4. And I get the same answer. But I think if you take out the common factor first, that saves a little bit of writing, a little bit of work. So my advice is to always look to take that common factor out first. Okay, we have one last example here. Example 5 with a difference of squares. Here we have an x to the 4th minus 81. And we'd like to factor that. So we begin by saying, well, x to the 4th, that's x squared. Would be what we would multiply times itself to get x to the 4th. 81 is 9. So we'd write that as x squared plus 9 and x squared minus 9. Now we're not quite done yet. Look at what's there. And hopefully you spot this x squared minus 9, which is also a difference of squares. The other piece there, x squared plus 9, actually can't be factored. We'll take a look at that in a moment, but for the moment, just write it down. And then x squared minus 9 can be broken up as x plus 3, x minus 3. Okay. Now you might be wondering, why can't I factor x squared plus 9? We can factor a difference of squares. Well, what's wrong with the sum of squares? Well, the reason we can't factor it is if you took that x squared plus 9 and rewrote it, you could write that so that it has 3 terms. The middle term is a 0, so you could put in a 0x. Well, now that it has 3 terms, we can factor it by saying, okay, we need things that multiply to be 9 and add to be 0. Well, the numbers that multiply to be 9 are 1 and 9, and positive 3 and positive 3. Neither one of those add to be 0, and so for that reason we conclude that polynomial x squared plus 9, and in fact it's true for any sum of squares, is prime and cannot be factored. The only thing you may be able to factor out of a sum is a common factor. Okay, so that's all you can do. So that's factoring a difference of squares.